So we've got our new group of students in. First graduates have finished. We've got them working on cervical passive rotation and seated cervical side bending passively, just for the purposes of assessment. We got some new stuff going on. Having fun, learning lots. This is actually one of the most unique solutions that I've ever seen to attempting to generate side bending in a lateral recumbent patient. So when we work from concept and we work from framework, people come up with this stuff that most would never think of. This is actually very interesting. Now I have to see myself doing this. That's great. Please don't trip. Please just don't trip. Okay. Thank you. The button will bring the screen back up and record, but first it'll bring the screen back up, and then when you press it again, it'll record. Anyways, is it recording now? Okay, perfect. All right, so we actually have a thesis experiment going on right now, and no, stop. I'm messing it up because I'm messing with you. wait. No, come on. Oh, dude, no. Yeah, there we go. So we have an experiment going on because we actually believe in thesis experiments, and good work, and sorry for making it weird. Now I'm between modules, so after our March 2025 module, I'm back to looking at things like data and spreadsheets. So one of the things that I'm doing for the student whose data this is, or this represents, they did rib springing and a control group. So essentially, I believe they did 2 rib springs on the sternum to see what would happen to inspiratory volume and expiratory volume. So we've got this data, and I mean, some of this you'll be able to see, and some of it you won't. I can do that. Yeah, so we've got the real number change. I don't necessarily know what the measurement is on the specific tool that they were using. So we've got -85 as an average for inspiration on the control group, and plus 179, or they did better at 179 units. And then it's actually, interestingly, 7.98% negative and 7.98% positive, whatever, blah, blah, blah. The idea here, though, is the t-test. So on inspiration, the t-test. So t-test is something that can show you with a pre and a post measurement if the pre-group and the post-group are noticeably different, with the assumption that whatever it was that happened between the first measurement and the second measurement was responsible for whatever difference does show up or does not show up. So when we look at the control group, we get a 0.35, many more numbers. The springing group on inspiration, we get, so essentially statistical significance is noted at 0.05 or above in most things. Physics has I think physics likes 0.01. Anyways, we've got a reading right here of something very significant. Now, what I wanted to note is that while there is statistical significance between pre and post on the spring group rather, it does mean it works better than nothing. But when we look at the amount of subjects who had a decrease in their inspiratory volume, it was 1, which is 4%. So it's 25 total in each control and test, or control and springing. So there were 16 who had their inspiratory volume increase, which means 64% of the time it does work more often than not. But there are people with no change. So there's 7 people, which means, as far as inspiratory volume or with rib springing, 7 out of 25 people, or about 30% of the people, have no change. It has no meaningful impact on their inspiratory volume. There could be multiple reasons for that. Some of it may be how they did their pre-test and their post-test. Maybe they performed it slightly differently. That is a possible confounding variable. But it gives us initial insight into, sure, it works. Sure, it's statistically significant pre and post measurement, but it doesn't necessarily mean, because it's statistically significant pre and post, that it does it as often as you would want. 64% of the time it goes the way you want. 20% of the time it does nothing, and 4% of the time it goes the wrong way. Right? So if we look at expiratory volume, we see something similar. So control, not statistically significant, pre and post. The rib spring group, it is statistically significant, but not as strong as inspiratory volume. So it does work better than nothing. But there were 8 people who the value, the measurement for expiration went negative. It went the wrong way, which means that 30% of the time it goes the wrong way. What we then have, or 32%, what we then have is 16 people out of 25, or 64% of the people in this sample. It went the right way, right? So that's what you want. And then one person, it did nothing. So although we see statistically significant values, which is what many people are looking for when you're reporting things along the lines of statistics, with healthcare, I would argue that the rate at which it goes the way you want it to go or you predict it to go is more powerful, because what it's showing is the variation in individuals and the rate at which it does what you would hope it would do. If it's 64% of the time, that's not horrible, but you can't go around saying that rib springing compared to nothing is statistically significant for improving inspiratory volume or expiratory volume and have that guide treatment. Because yes, it does, in a statistically significant way, improve inspiratory volume or expiratory volume, right? But you see the average percent change is 5.28%. That's not that big, right? And part of the reason it's not that big is because we actually have 32% of the people go the wrong way, and one person or 4% of the people do nothing. So this information is probably more important than the average. The average is a collection of all of the data, so it gives us some idea of spread across a population or spread across a group what we would expect to see, but it doesn't tell us what's going to happen to each individual. Good, bad, or indifferent in healthcare, I'm a little bit more interested in what happens to each individual. I need a lot of individuals to figure this out. The average matters, the average is meaningful, but the rate at which it goes the way that I want it to go is probably more important than the average rate or the average direction of change. So something to keep in mind as a result of something that I'm doing in between modules, looking at student data. So the student data is actually really interesting. It's just if I report it one way or the student reports it one way, it looks awesome, right? So statistically significant rib springing does improve both inspiratory and expiratory volume. It does. However, it's about 64% of the time that it actually increases those values, whereas the remainder, it goes the wrong way or does nothing. So we want to be aware of that. That has a lot of value to us.